Setup time reduction techniques are often referred to as SMED, which stands for Single Minute Exchange of Die, from the classic work by Shigeo Shingo at Toyota. And he didn't actually mean single minute, but that changeovers should be roughly less than 10 minutes. But why is this so difficult? Why can't changeovers be fast? Well, here we see an example of a changeover for a press line. Can we do this in less than 10 minutes? The tools need to be changed here weigh tons. And this is what Toyota also recognized, as the exchange of dies for stamping car body parts used to take several hours. The dies needed to be changed for each different model and weighed tons and had to be assembled then into the stamping machines with extremely exact tolerances, less than a millimeter. And reducing the setup time would improve the capacity and thus allow flexibility in production. But how to do this under these difficult circumstances? And here we look at the SMED approach. There's 6 different stages. Stage 1 is to carefully analyze all the tasks that are part of the setup time, part of the changeover time. And here, it's very much advised to make a video, or even several videos if there's different shifts. So you want to measure then the changeover by checking to see which tasks are internal tasks and which are external tasks. Now what this means are that internal tasks can only be executed while the machine is stopped, while external tasks are tasks that can be done while the machine is operating. They can be done before or after the actual changeover occurs. Now, companies often tend to use internal setup tasks, which means that even without making any investments, without having duplicate tools or without any extra parts, you can actually improve setup times by just looking at whether a task can be moved before or after the shutdown. And so here in stage 3, you want to try to move external tasks outside the changeover. And then stage 4 is to investigate how the internal tasks that have to be done during the shutdown can be further shortened. This can be through a process of incremental improvements, for example, training, for example, using power tools, that type of thing. And of course, the external steps should also be improved. That's more to make sure that everything's ready to go when the shutdown starts, but also to make sure things are standardized and you keep the overall quality of the process very high. So finally, you want to standardize the entire process, procedure, and monitor. So here we have for stage 1. Measuring the total changeover time, we're looking at a changeover analysis sheet where what you would do is carefully look at the changeover and list all the different actions and their duration. So, for example, here we have an example of a filter change in a chemical factory. So you would, for example, step 1, get the crane remote control, takes 3 minutes and 50 seconds. Move the crane to the filter, takes 5 minutes, 25 seconds. Somebody has to go and get the tools, takes 1:45. Unscrew filter ring, etc., etc., etc. This goes on. Here's first 18 steps. Here you have 26 steps. Finally, returning the crane, taking 30 seconds, and overall a total of 1 hour, 49 minutes, and 40 seconds for this filter change to be done. So that's part of stage 1, listing the steps and measuring all the different times required. Then, moving on to stage 2, you want to split the activities into internal and external steps. And again, internal steps, these can only be done when the production is shut down. They must be done during the changeover. For example, removing dies, changing blades or tooling, loosening, tightening of critical bolts. External steps, on the other hand, are ones that can be done during production, and the machine can still be operating. It's simple as cleaning up, tool preparation and retrieval, maybe even assembling some subparts, and documentation or paperwork. And what's important is that a high percentage of operations are usually considered are usually external steps that could be done before or after the changeover process. This is just an example from an extruder, so a machine that presses out material like metal or plastic into a certain form. And these are used, for example, in tire production for producing the rubber. And you could have the steps such as the extruder cleaning or some type of screw changing that has to be done internally, that has to be done while the extruder is stopped. Those are steps that cannot be done as preparation, and of course they're taking away from your productive time at the extruder. But so we were saying things like documentation or certain types of cleaning or tool preparation can be done while the extruder is working. It can be done before or after the changeover. So then you want to make sure, stage 3, that you're moving your external steps outside of the changeover process. So as we were saying before, make sure that you wait till the changeover is complete before you do your paperwork. Make sure the equipment and the tools are ready to go. Now, here, what you may notice is that you're actually adding new steps. You may even be buying more parts, additional tools, so that all the preparation can be done before the changeover starts. But of course, these type of preparation steps don't take away from the productive time. Now, the next important part is to shorten internal steps. And for example, here we have tooling optimization. So you could, for example, make sure that you progressively, for example, eliminating first a toolbox, replacing with a tool board, going one step further, making progressive improvements, installing this tool board closer to the equipment along with some of the necessary pieces, and so forth and so forth and so forth, finding even better ways, instead of using screws, actually having wing nuts, in order to improve your internal steps, and this also helps to reduce variability, any missing tools or errors, for example, and reducing waste such as motion. You don't need to you can quickly pick up the tools. You don't have to do any extra assembly. Now I have an example here of stage 4 from where I worked in semiconductor production. This is an example of a load board changer in the silicon wafer test. So just really quickly, in the wafer test, you want to sort the wafers. So they're normally produced in these batches of, say, 20 or 50 wafers, and you want to make sure they're back in the right order in case they were out of order during the previous processing steps. And then you test them, and in the case of memories, you can sometimes repair some of the faulty memories with a fusing process. Then any chips that didn't yield, that didn't perform correctly, you want to mark them. You can either physically ink them or you can mark them with electronic test maps if they're failed. So that means they won't get then packaged later. Then there'll be some kind of optical inspection, just a last check, and those wafers will then be sent to be assembled into individual chips. So we're going to look here then at the testing process. And in this process, you have a tester, which then has a test program loaded on it, and it will test each of the individual products. And so the wafers then are separated into different lots or batches of different products. So the wafer then is mounted here onto a flat chuck, and a particular probe card has to then be attached to the tester head, and it'll have very, very fine contacts, which will then go down to test the wafer. Now, in some cases, you also need to have a so-called load board, which will act as an interface between the test head and the probe card. And the load board as well is product specific. Every time there's a different change in product, you need to have a changeover for that load board and for the probe card. And before, the load board was actually screwed into the tester head. And so every time you needed to change it, you had to unscrew the screws. And so the improvement here was that they implemented a kind of a CD changer type assembly, so that you would push the button, And then the load board would pop out, remove the old load board and put the new load board in, press the button, slide everything back in, and you could start the test. And this idea then reduced the time that it took for this changeover. And it came actually from the operators in the test hall who were very familiar with the process, and was a very good example of shortening internal steps for something that had to be done when the testing was stopped.